RAPID TCT 2019 has a huge draw thanks to a lot of 3D printers. And we're not talking tiny little consumer machines. These are multi-thousand, possibly multi-million-dollar machines. Creative 3D Technology is right behind me. It's one of the more popular ones at this show because what it can offer. We're going to talk about this machine and all the other ones we saw right here on 3D Printing Nerd. I first saw the Kodak machine a couple years ago at CES, and that's where I met Demian, but they've done a lot since then, and Demian is here to talk about it. Hey, Demian.
Hey, how are you?
What the heck, man? You've got a machine hanging from rope, and I assume 3D printed parts here?
Yeah, exactly. So it's hanging from nylon 6 printed parts that are very high traction resistance. I'm currently printing this great nylon part, very detailed, that you can see.
Let me see this. Okay, but it's nylon, so I can move it and push it around and it's not going to break.
Exactly.
Wow, and so it's printing this high of detail while it's just kind of hanging here, swinging around?
Exactly.
That's kind of cool.
This kind of detail and in higher temperature materials, which is something that you may not see in many desktop 3D printers out there.
Well, let's talk about what its capabilities are. What's the build volume?
The build volume is about 8 by 8 by 9 point something.
And dual extruder, is that right?
Dual extruder with lifting nozzles. We currently have a line of 11 different materials, from normal PLAs to 3 different grades of nylon.
And it just right out of the box, it can do nylon, no problem.
Right out of the box, it can do nylon with our preset profiles.
And fully enclosed, so ABS is no problem. You've got, is there a fan in the back blowing the air out?
There's air filtration with a HEPA filter and activated carbon, so ABS is good to go.
And connectivity, wireless or Ethernet?
Yes, it has Wi-Fi, Ethernet. It's connected to the Kodak 3 cloud, so you can have an unlimited fleet of printers in different locations, managed by your cell phone or computer. And yeah, it has a built-in camera for remote monitoring.
Wow, well, I know you got a machine over there with ABS. Let's go take a look at that and continue the talk.
Great.
So this machine here, this one inside the booth, this is printing ABS right now, right?
Yeah, it just finished printing ABS. Actually, you can touch the build plate. It's still hot. It printed this part that has very fine details, no warping, no delamination. It's 100 micron, and you can see difficult to have such a print with a desktop printer.
It's perfect.
This is an ABS part with HIPS soluble support.
So the black is HIPS.
Correct.
And how would you dissolve that?
With limonene, with a limonene solution.
Oh, that's right. Okay. And this machine can do that because it'll have HIPS on one side and ABS on the other?
Correct. That's it.
This print is super clean. Now, with the machine, what's the retail cost of this bad boy right here?
It's $3,500, and you can benefit from our design to print services. So basically, we're offering a service where this is basically you get any 3D model, and you have our designers in our factory work on that model to make it perfectly printable on our printer for you. They can create customized profiles if you have a complex geometry that wouldn't go with our preset profiles. And we do the work, so you don't have to worry about the whole thing. It's basically a comprehensive approach where we offer hardware, the materials, the software, and the service.
That's really cool. Well, Demian, thanks for this. I'm really looking forward to maybe playing with this machine someday.
Absolutely, yeah. We'll be happy to have you do that.
That'd be great. Hey, happy RAPID to you, my friend, and good luck with the rest of the day.
Thank you. You too. Have a great day.
The Aeon 3D booth is actually printing with some PEC material, and I actually met up with my boy Randeep here, who dresses more like how I do, not a suit and tie. Hey, Randeep.
The straps with the shoes, yeah, everything. How are you?
I'm well. Well, I mean, you've got a fantastic flannel. I'm from the Pacific Northwest, so you represent.
I'm from Seattle.
I live in Seattle.
I was raised there in Bellevue for 14 years.
Oh my God, up top.
Yeah, there you go.
What? Did we just become best friends? Yep.
Sweet.
Now that we've become best friends, tell me about this machine right here.
Okay, so this machine is similar to some of the machines that you might have seen at the lower end, like your entry-level machines, but it's really, really hot.
How really, really hot is really hot?
It's like 120 Celsius, so water would be boiling right now. Why we do that is because we're printing really high temperature materials. When you're printing hot on the material. So if the material is too hot, it actually causes warping and stressing. So we have the temperature really high so we can control that. So we can produce parts that are super strong. Like this could go on a spaceship right here.
Oh, a spaceship.
It's supposed to go on a spaceship. So this is a circuit mount for a rocket out of a material that can handle almost 260 Celsius.
Wait. The temperature around the material can get to 260 C, and this will be like, no problem.
Yep. I wouldn't go too much past that, but yeah, 260 C is what it's rated for.
Oh, it feels good. What is this?
It's a carbon fiber PEK, P-E-K-K. So it's kind of like PEEK, but a little bit different.
PEEK is polyether ether ketone.
Yeah,
PEK is polyether ketone ketone.
exactly. The material is really expensive itself. That's like $600 a kilogram, but you don't have to go through all the machining process that aluminum does to get there. So per part, it's actually cheaper.
Oh, and you don't have to invest in a metal 3D printer, which is usually fairly cost prohibitive.
Yeah, we're talking hundreds of thousands, if not sometimes more. Yeah.
Wow, dude.
So yeah, it's a really crazy cool material, and it's really cool that you can use this stuff in real life now. Like the parts are good enough to use off the machine.
That's crazy. How do you get the supports out?
This one here, you just break them out with a set of pliers. So the same way that you'd break out your supports on your ABS or your nylons or your PLAs.
Okay,
So
cool.
It's the same kind of process, but just higher temperature.
But we're not talking about the materials. We're talking about how this machine can print all these awesome materials, right?
Yeah, exactly.
And it can.
It can. So this is a PEEK part, but carbon
Here,
fiber
trade me.
reinforced. So that's like an airfoil, so that's super light and highly stiff.
Oh, that's and very light and very stiff.
Yeah.
Oh, I see. And it's a wing shape.
Yeah.
Or
So-
a foil.
Foil.
Yeah.
Or we have like this here, which is like nylon. So the same nylon that you see everywhere and pretty much everything, you can print it now too.
Well, I can print some nylons. Is it similar to the nylons that I use?
Similar, but it'll have better layer strength because it's inside of a heated environment. So you're bonding, you actually have higher bonding because you're printing on a hot thing already.
Oh, so the layer adhesion is better within this because it's already all hot.
Yeah, exactly.
Wow, that's cool. So let's talk about the specs of the machine. What's my build envelope here?
So 18 by 18 by 25 inches, and
It's huge.
it's huge, it's enormous, and it can go up to 120 Celsius inside as the chamber temperature, and you can extrude it over 500 Celsius. So you can pretty much melt any plastic that exists right now.
What is the hottest plastic? Do you know?
There's like, in the thermoplastic space, PEEK is the best. It's
Oh, it
the
is,
hottest,
okay.
Yeah. There's some plastics that go higher, like the polyimides, but they can't be melt processed, so people are still trying to figure out how to use those. But yeah, PEEK is actually the highest performing thermoplastic in the world right now.
That's cool. Okay, so let's say I was a business or I was a person that needed to get something like this, and the Aeon 3D machine is what I wanted. What is it, the M2? What sort of charge would I see on my credit card?
You see about a $42,000 charge right now.
Okay, that seems like I've spoken to other people here, and that's not out of the ballpark.
No, I think it's actually really, really reasonable for a machine of this caliber right here. So our whole thing is we want to make it affordable so that people can actually adopt it. You know, if you spend $250,000 in a machine, then you just can't really do that.
That's true.
Yeah.
That's true. Hey, Randeep, it's really good to meet you, and thanks for making me come over here.
Okay, thank you so much.
Have a good rest of Rapid, my friend.
You too.
Seattle rocks. We're at Rapid, and this has been a long time coming. I've been meaning to meet up with Ethan here for the better part of almost 2 years, and finally in Detroit, we meet. Hey, Ethan.
Hi.
You have an insane machine that I've been wanting to see for quite a while, but just haven't had the chance. And now that I see it in person, it's incredible. Give me a breakdown of the specs of this machine right here.
Sure. So it's just for a disclaimer first. This was our last prototype before our pre-production unit. So since then we clean up the UI, interface, and a few other wiring and a few other things. But in essence, it's the same thing. Large format, independent dual extrusion 3D printer that takes the best of a lot of other 3D printers that are very specific in their nature and merge into one. So you're getting volume without the sacrifice of precision. You can still print multiple things at the same time, industrial materials. You can do it all. Since I ran a 3D printing refurbishing business for about 5 years before I started this, I wanted the best of a lot of different 3D printers I've had experience with in one printer, and I just didn't find something like that out there.
Well, you sure created a masterpiece. You said it's printing with 0.6 nozzles right now in mirror mode. It looks like it has purge buckets on the side. Is this a custom-built extruder, or are these Vontex or something else?
So we use E3D products for the hot ends. We use two Bontex for either line of filament. So you have Bowden for pushing and direct drive for pulling. So you get a lot more torque with that. You get the advantage of direct drive and the advantage of slack in the line of Bowden. And we also we try to put ourselves with a lot of the best brand names. We have genuine high-end rails, THK ball screws, THK or high one. We're still debating between the two for our final models. Try to use the best we can in all the aspects where it directly affects print quality and optimize for cost savings on the rest of the frame and pass it on to the customer.
Well, before we get to the cost, what are the specs as far as the build envelope? What's the X, Y, and Z on this?
So if you're using both extruders at once, you do have a little less volume. You have 460 by 910 by 675. Or if you want to print with just one, you get a little extra volume on either side. So you get about 500 with that.
That's crazy pants. And I know this is a large build volume, but you reach back here, and go ahead and grab that right back here. just because you have large build volume doesn't mean you sacrifice the quality. And what was this printed with, and what nozzle?
This was printed with a .15 millimeter nozzle on our detail tool head, so everything's quickly interchangeable. You just unscrew it and then you can plug it in and be able to print. Whole new application, 3D printing essentially. So if you want a really fine outer finish, you can print with a detail tool head, and you want to print something really fast on the inside, you can make a stronger infill material while doing a really fine outside and reduce your print time drastically.
Oh, and that's the beauty of having two different print heads, is that you can have different materials, or you can have different functionalities of each of the print heads.
Yes, especially if you're printing something really large, you can do it a lot quicker that way. Or you can have your soluble supports and whatever else you'd like to do.
What's your customer for this? Who do you envision as the people that want to buy something like this?
So we tried being right in a sweet spot of everything with our pricing. We wanted to price it cost effectively to the top end of consumers, since that is around the cap of what they're going to be at, but also at the middle market as well, for the people that are looking for something above 10,000 but a bit less than like 50,000, and something for their small businesses or startups, things of the sort, or replacing their outsourcing prototyping to something in-house. And it's also still big enough, fast enough, and has a lot of same features as the industrial ones to compete on the industrial market as well.
Like if I was going to hand you a credit card, how much would be on my credit card at the end of the day?
Depends what add-ons you'd like, but if you're pre-ordering it, we sell it for $8,000 as a pre-order now. We offer additional benefits. For example, you join our pre-order club, essentially you get additional features, and you get discounts on every single future product we'll have. Filament will resell, tool heads, you get exclusive price on all that. Ruby tip nozzles, additional acrylic customizability, and you get it first before anyone else, and it's just as tested and quality checked as any other machine. Your first print comes on the plate, and we're not going to ship to you unless it does exactly what we say it does.
Wait. You said eight?
8,000.
$8,000?
Yes.
Dollars. Okay, because I have machines in my house that are a quarter or less the build volume, but are definitely not a quarter or less the price of this. How do you do that?
A lot of it's our business model. We just do things a little more efficiently. And a lot of these big printers around here at this show, you can certainly price a lot more effectively, since it's not new technology anymore. And in the industrial and prosumer market, it doesn't need to be priced like that anymore. And that's where we want to disrupt the model.
Well, for people to help enable you to disrupt the model, where are they going to go to get more information about this?
Create3technologies.com. We have everything on there. So you can certainly look us up and join our pre-orders as well if you'd like to.
So one more thing, I think this is interesting. You showed us the really small piece, and I thought, hey, you know what, this stool is cool, haha, you printed the legs, but you printed the stool itself.
Yes, so it was all in one piece. We used brown filament just for the top and blue for the rest of it, but yes, because one piece print.
That's an accurate representation of real life, right? And it's light, and it works, right?
Yeah, you can see it. It was printed in about 2 days.
2 days?
Yep, we had one nozzle do the finer outside and a thicker nozzle do the inside. It was
So
one of our earlier tests on our earlier prototypes, but yeah, yes.
Well, this is strong. So, okay, then I guess one more question. The prints are strong. Is the frame strong? Because, I mean, with this sort of build volume, any sort of shift in the frame is going to throw the print off. Is this pretty sturdy?
It is. I mean, we have plenty of photos of me sitting and standing on it. You have no issues. You don't need those custom metal bent frames to have the same level of rigidity. And we pass the cost savings on to the customer with it.
Ethan, this is wonderful. Thank you for finally being somewhere where I'm at, where I could see you, and I wish you the best of Rapid.
Thank you for stopping by.
Yes! A while ago, I produced a video where I went to Longmont, Colorado, and we talked about the H series from Diabase, and look what's at Rapid. Hey, Steve.
Hey, man.
What's happened since the video went out? How has it been going?
It's great. We're actually shipping product. That's the main thing. So in February, we started shipping these machines. This guy is serial number 18 at the moment. So yeah.
Wow.
The rest are with customers and working well as far as we know. So yeah. So let me get a print started, actually get a milling cycle started for you.
Okay.
Yeah.
Oh, well, can I touch a button?
You can. You certainly can. You can hit the OK button.
I can hit the OK button. I think I remember we showcased this, but we didn't actually put it on the machine, right?
I think you took it off the machine and you broke part of it. So yeah.
Sorry.
Yeah, let's get started. Hit OK.
Here we go. So
Okay.
it rotated the head.
Yep. So it brought down a ball end mill. It's going to come down and start machining. So it will do a contour tool path first. That it's kind of just hitting a couple of spots on the inside of the part. Then it's going to come around smooth the outside layers, and then it will do a spiral toolpath from inside out. Then it'll switch tools again, bring up a chamfer mill, and that'll come and etch the part. And this is what we're showing right here. So it's just a little puck that has our logo on it, but it shows you the detail that we can do with this machine. So we can smooth out the surface finish, get rid of the layer lines.
And what material is that?
That is PETG, but the part that we printed first had an adhesion layer of urethane to make sure we got a good grab on the bed, and then it has a support material layer, or several layers of support material, and then the parts printed on top of that. Yeah.
Wow, it looks really good.
Thank you. Yeah, we agree. Yeah.
And it's hypnotizing to watch this machine work because the bed moves, but you have the rotating head. I think the thumbnail I made for this video was probably one of the best I've ever made.
What was that?
Well, just because it showed the machine. It was like this dark, sexy picture.
It is dark and sexy, yeah, we agree.
So one of the things I'm seeing on the video there, you've got a 5th axis, is that right?
Yeah, so we can show you that over here. Here's a part that is printed in standard 3-axis mode, so Cartesian mode, and then we use a 4th and 5th axis to mill it. So you can see you can get a very smooth surface finish with a milling cutter. Yeah.
Oh, wow. Wow.
Not bad, right? Yeah, so that's a 4th axis unit, but these rotary axes are modular, so we can also set them up in 4-axis mode. So this is a print that's done in 4 axes, and this is TPU, so it's flexible, but the difference here is that the layer lines are circumferential, so the part is really strong in the radial direction. So for things like casts and other components that you need strength radially, it's much better to do in a rotary axis setup like this. Yeah.
Well, it makes sense, and it's going to be phenomenally stronger, right?
Yeah. If you printed this in Cartesian, you'd have a bunch of overhangs and you'd have poor bonding between layers. But since we're printing rotary, then you have a much stronger part in the radial direction. Yeah. And then this display is showing you different hardness of material that we can print and then refinish. So if you look at the prints, they're not beautiful, but that's kind of the point. We print with a very big nozzle, we can print faster, we can push out more material, and then we can come and clean them up to a nice fine surface finish afterward. And we can do that we can do that with rigid materials, but we can also do that with elastomers. So this is something completely new at the show that we're debuting. So this is a 60A durometer that's first printed, and then it's burnished with a hot ball tool. So there's no one else in the world doing this at the moment. So
no, there's not. World exclusive.
That's right. Yeah. Yeah. So what do you think, man?
This is incredible. I like how you just ran with it. Like the machine had promise, and then you guys were like, "We got this," and then you just took off with it. It's amazing.
Exactly. So the way we look at this thing, it's a platform. It's a mechanical system that is modular and allows you to do a lot of different things already. But in the future, we got plans for a lot more tool heads, a lot more capabilities that we're going to add. So yeah, we're excited.
This is amazing. Steve, thanks for the time, man. I really appreciate it.
Thank you, Joel. We'll see you, man.
See you later. You may have seen recently where I did a video on the Makergear M3 in this really awesome chess set. We're at Rapid, and we're at the Makergear booth, and we're here with Rick. Hey, man.
How you doing? Good
You've got some cake in your hands, and that's because you are now 10 years old.
We're celebrating our 10th anniversary. We started in 2009. 10 years ago, I was in my garage making parts one at a time for people that were making their own 3D printers. That's how we started.
Massive congrats, man.
Thank you.
But 10 years ago, you didn't have this. This is the Makergear. Wait, what is this called?
This is the Ultra One.
That is insane. That is huge. Here, I'm going to come around. So, obviously, the M3 is a great prosumer model. This must be an industrial workhorse.
This is our introduction into the industrial space. It's got a 16 by 14 by 13 build volume. And as we'll step over and see the core in a minute, it is built to be reliable in industrial, heavy use environment.
Well, heavy use, that speaks with this over here, right? Yeah, put your cake down. Let's walk over here.
So what we have here, this is the core. This is what's inside the Ultra One, so you can see how it's constructed. This thing is a beast. It's reliable. It's built to be strong. This is the machine that's built to go into an environment where it's going to be heavy use, production 3D printing.
Okay, I'm going to have to lift this myself. You ready, Sean? Here we go. So, oh my God, that is
solid.
Wow.
That's solid. So this is cast tooling plate, so it's flat. linear rails. You can see all the precision machining that goes into this machine. So we put a lot of work into making a really rigid frame so that when you actually are printing, layers that are a thickness of a sheet of paper over and over and over again, weeks, months, years, you're still getting a great result.
Well, this is fantastic because the M3 is a wonderful workhorse machine. This is like next level. So if a business wanted to pick up something like this, they wanted something bigger than the M3, what would this set them back?
The retail price of the machine is $12,500.
That doesn't seem bad for the volume and the reliability.
How hard it is to build these machines, we think it's pretty reasonable.
Well, Rick, congrats on 10 years. I know you've got a mug over there for me, but I just want to shake your hand. Thanks again, man.
Thank you very much.
I'm here in the Stratasys booth next to an amazing machine with a man holding a really awesome part. This is Thomas, and he's going to tell me why this is so cool. Hey, Thomas.
Hey, Joel. Nice to meet you.
Good to meet you.
Good. Yeah, so this is our TPU material. We can do full 14-inch tall parts with support material. Yeah, it's really fun. They're fun to bend, fun to squish.
It feels like a molded part, like it was born this shape.
Yeah. No, it's a typical FDM process, like hobby level printers. Just the next step up.
Yeah, I mean,
yeah. We do protective cases with them on factory floors. So if people want to fight like that, then they're fine to go.
That is cool. So what machine made this?
So this is our Stratasys F123 series printer.
Is that this one?
Yeah, so this one right here is the 370. It's the biggest 123 series that we have. It can do TPU material, it can do a PC ABS blend, ABS, ASA, and it can do all of them really well.
And why is that?
We have a heated oven. People are aware that patent's going to be running out soon. Joel just mentioned that. So as a company, we're expecting to see more of that in the future.
Which could lead to more innovations, correct?
Yes, as a hobby level fan, I'm excited about that. But as an employee of Stratasys, maybe not so much.
Well, besides the heated, okay, so it's not a chamber, it's an oven.
Yep.
And it is filament based, right?
Yes, all filament based, just like Lulzbot.
So then this is a material, this is a filament, and it extrudes it through a nozzle, right?
Yep.
The nozzle, though, doesn't look like any nozzle I've ever seen before. Is what makes it special?
So it's longer and skinnier. It's about the same heated length as a super volcano. So it's a long heated zone. Yeah, that's probably all I should say about that right now.
So as far as this part, this is TPU. I don't see where. So usually supports leave a scar on the material. What supports supported this?
So we have our SR30 material. So it's a soluble support, kind of like PVA, except we need more chemicals other than just water to wash it away.
That's really cool. That's really, really cool. So then, obviously, this is not hobby level, but if a company or corporation needed a machine that performed like this, what would this set them back?
This machine here runs about $60,000. We have a smaller, the 120 is a little bit cheaper. It's a smaller, less capable machine, though, and that's more in the $12,000 range.
Oh, okay. What about that large one behind Sean right there? Let's go. Can we go talk about that one?
Yeah, let's go see that one, and I'll tell you about it.
Thomas, this machine is slightly larger than that other machine. In fact, I could probably sleep in this machine. What machine is this, and what does it do?
Yeah, so this is our Stratasys F900. This is capable of printing 36 by 24 by 36 inch parts. Big solid Ultem parts.
Big solid Ultem parts. Yeah. These are engineering materials.
Yes, engineering grade, high-end, high temperature resistance, high stiffness.
So that thing that's in there, that engine block, that was printed on this machine?
Yeah, it was on this machine, took about 8 days to print.
It looks so good.
Yeah, it's beautiful. These parts are absolutely gorgeous.
Can I hold it?
Yeah, go for it.
Look at this! This is crazy.
Yeah, it's a beast.
Wait, say that again.
Yeah, it's a beast.
And this is 8 days of Ultem printing?
No. This is our ABS material.
Oh, this is ABS. Okay, so it could do Ultem if it wanted to, but this is 8 days of ABS.
Yes, correct. Yeah.
Okay, I'm gonna hand it back to you because it's ABS. I don't want to break it. It is awesome. So then, this is a bit of a flagship situation, right? This is an amazing machine. We talked about the price of that one. If a company or corporation wanted to get into this thing, what sort of charge would they expect to their bank account?
Almost 10 times the amount. It'll be more in the $400,000 range.
Oh, okay.
Yep.
I mean, I've seen machines at RAPID here that were in the $1 million range, so that seems affordable.
Yeah, it's affordable, and the use case we have for customers that buy this type of a machine helps them pay it off relatively quickly, generally.
I guess I got to get into manufacturing, don't I?
Right, yeah, I don't know if you have space in your garage for this one, though.
My wife would kill me. Thomas, thank you so much.
Yeah, appreciate it, Joel.
Have a good rest of Rapid, man.
Thanks, I will. You too.
Well, that was a bunch of fun, and I hope you really enjoyed Ethan and his duo here. This is an amazing machine. You're going to want to look more into this. And a big thanks to FlashForge for bringing us out to Rapid TCT 2019. Hey, look in the video. If you made it this far, you're awesome. And don't forget to hug each other more. I love you all, as always. High five.